Well, this question is bananas. Well, no pun intended, but our theme here today is we're going to look at the rate at which customers in a grocery store removed bananas from the display table. And then as that table starts to, the supply runs low, we're going to look at the rate at which the employees at the grocery store add bananas back into that table. So again, this is kind of a classic simultaneous rates question. It is calculator active, thank goodness. And so one of the things that I'm going to recommend right away, as soon as you grab your calculator, is let's go to the y equals feature and let's enter in this function right here. And again, we're going to be in radian mode as soon as we see that sine function being used. And that's going to be the rate at which customers remove bananas T hours after the store opens. And then as soon as we get that typed in, let's type in the second function. This is going to be the rate at which the employees start to restock that display table. So we're adding them back in. So we've got one function removing bananas. The second function is adding bananas. They're both measured in pounds of bananas per hour. And then let's go back and highlight this part. When the store first opened, there were 50 pounds of bananas on that display table already to begin with. All right. So let's see if we can put this together. How many pounds of bananas were removed from that display table during the first 2 hours? So this is what we call the net change theorem. And anytime you integrate a rate of change, the answer is going to be the net change and how much a function is changed. So in this case, we want to integrate from 0 to 2. We're going to be integrating the f of t function. We'll perform that integration on our calculator, and we're going to get about 20.051 pounds of bananas. I just double checked the directions to make sure they didn't want me to round to the nearest whole number. It doesn't look like they do, so we're going to keep those 3 decimals. Let's go ahead and see what B's got cooking. Oh boy. So the first thing I'm going to do is, now I use a TI-84 Plus. So what I can do for my home screen now is I'll go to the math menu. I believe option 8 is the derive one. And so I'm typing in, I want to derive. I think the first thing you have to input is this X right here. And then you can, hopefully you don't have to retype that entire F function. If you go, I think it's alpha F4, you're able to kind of just import a Y sub 1, evaluate it at X equals 7. Technically that's a T value, but your calculator is going to treat it as an X. And you're going to get an output of negative 8.120. Now, the College Board really doesn't care for the calculator syntax. So I would not write any of this on my exam packet. And all I would say is f prime of 7 equals negative 8.120. Now, the most important part is we've got to explain the meaning of this value within the context of the problem. And I think if nothing else, you're going to take a lot away from this, hopefully. Now, in the most general sense, when I see f prime, we're talking about the rate at which f is changing at t equals 7. But I want to be a little more specific than that, especially within the context of these bananas that we're dealing with. So I'm going to go ahead and I'm going to hit pause. And I'm going to try to type in my response here. So I said, this at t equals 7 is really saying, okay, after the store has been open for 7 hours. And now what you're going to do is I'm basically rewriting the language of f. And I said the rate at which customers remove bananas from the display table. And then we get into the real f prime here. F is changing at a rate of negative 8.120 pounds per hour. Because again, remember, F was already pounds per hour. So when you derive that, you're basically attaching another per hour. Another thing you might want to do, depending on your preferences, see, this word changing is a very neutral word. If you want to say decreasing, you can, but then this negative would not be there. The word decreasing kind of takes the place of the negative. Moving on to part C, they asked, is the number of pounds of bananas on the display table increasing or decreasing at t equals 5? So the first thing, I might go a little bit overkill on this one, but I think it's gonna be worth it. Hopefully it deepens your understanding of this process here. So is the number of pounds of bananas, I want to try to write a function that models the number of pounds of bananas that we have. And so if I said A equals the amount of bananas at any time would be the original 50 that were there when the store opened, plus how much has been added back by the employees. Ooh, I just caught something. Now, because the upper bound is T, I need a different dummy variable right there. I'm going to just go with a generic X minus the number of bananas that were removed by the customers, and again, I'm going to use a dummy variable right there. Now, basically, we want to know, is that function that I just wrote, is it increasing or decreasing when T equals 5? So I'm going to derive what I just wrote, evaluate it at 5, and whether that answer is positive or negative is going to dictate whether this A of T function is increasing or not. So the derivative is going to be, let's see, the 50 turns into a 0. We then apply the second fundamental theorem of calculus. I'm going to evaluate A prime at 5. And again, I can use my calculator to evaluate these real easily. Quick sidebar here. What I'm about to write in green, I would not write in my test booklet, but from your home screen, you could go alpha F4, grab that Y1, type in your parenthesis, type in your 5, minus, and then go back to alpha F4, grab that Y2 function, and again, type in your 5. The only thing here is I might have screwed this up. You just have to be careful of how you entered these. This probably is your Y2. This is probably your Y1. I'm guessing this is probably Y2 should be, Y2 is probably your G, I'm guessing, and then this one's probably your F. But either way, just be careful. Spit that out. Calculator is going to be about 2.263. Or I should say negative 2.263. So basically what we're saying is if G is the rate at which the bananas are being added back to the table, F is the rate at which they're being removed by the customers, the only way this answer could be negative is if the customers are removing the bananas faster than the employees are adding them in there. So ultimately, the amount of bananas or the number of pounds of bananas is decreasing. The number of pounds of bananas is decreasing because A prime of 5 is less than 0. Ding, ding, winner, winner, chicken dinner. All right, what's D got cooking for us? So how many pounds of bananas are on the display table at 8? Well, again, here's another, we kind of reap the benefits of what I've already written. That function A of T, I'm just going to evaluate that function at T equals 8. So you've got the original 50 plus, let's see, oh, you know what? I need this lower bound to be a 3 because the employees didn't start adding the bananas back in until the 3 hours after the store had opened. So I gotta make sure I get the correct lower bound there. All right, minus the integral from 0 to 8, and that would be F, the rate at which the customers removed them. And again, just plug this all into your calculator, and you're going to get a nice 23.347 pounds of bananas. And that's an instantaneous snapshot of how many bananas, at least pounds of bananas, are sitting on the table precisely when T equals 8. So, ladies and gentlemen, I think you just survived a great question about bananas. And if this video was helpful and you were able to take something away, please hit subscribe, please hit like, share it with all of your friends, and we're going to get everybody revved up for this AP exam.